Welcome back. We're into week 3, and this is part 1 of our week 3 presentations. We're going to talk about solving quadratic equations and graphing, and I hope by now that you're an expert at factoring, because you will need those skills as we go on through this week and next week. So first of all, what is a quadratic equation? We've been working with quadratic expressions. So a quadratic equation is just like one of our expressions, but it has an equal sign in it. And the thing to remember is that it has a degree of 2. A degree of 2 just means that the maximum exponents in the equation is 2. The general form of a quadratic equation is, like we've seen before, ax squared plus bx plus c. So we still have our a, b, and c, but this time they're equal to 0. And again, we have to remember a cannot be 0 itself, because then the x squared term would be gone and the equation would be linear. Now, the thing we have to remember in quadratic equations is this zero product property. That's the concept that will allow us to solve quadratic equations, to figure out what numbers work to make the expression equal to 0. It says if two factors are multiplied together and they equal 0, their product is 0, then at least one of the factors has to be 0. So in mathematical terms, if we have d times e, a factor times a factor, equal to 0, that's true if and only if either d equals 0 or e equals 0. One or the other has to be 0. So there's our zero product property written at the top. And how does this help? Well, let's pretend we have two factors, x plus 4 times x minus 7 equal to 0. The zero product property allows us to say that one or the other of the factors has to be equal to 0 for the equation to be true. So in order to solve it, we can break that apart. We can say the first factor, x minus 4, equals 0, or the second factor, x minus 7, equals 0. So now we have two little mini equations, and I'm sure you know how to solve those. We'll just think about how to solve each one. X plus 4 equals 0. I'm going to subtract 4 from each side. X minus 7 equals 0. I'm going to add 7 to each side. On the left equation, I end up with x equals negative 4. And on the right-hand side equation, I end up with x equals 7. So those would be my two solutions for that quadratic equation. The thing that I have to think about now, are those the right answers? Is this correct? How do I test it out? How can I check it? One way to check it would be to rewrite our original equation, x plus 4 times x minus 7. And if you're thinking about how you check answers, we would substitute. So in the left-hand equation, x plus 4 times x minus 7 equals 0, I'm going to substitute 4 for all the x, negative 4, excuse me, for all the x's. And in the right-hand equation, I'm going to substitute 7 for all the x's. And test out, do I get 0 on the left-hand side of both equations? Well, when I replace the negative 4 in and the 7 in, I get negative 4 plus 4 is 0, and negative 4 minus 7 is 11. And on the right-hand side, I get 7 plus 4 is 11, and 7 minus 7 is 0. So 0 times anything in both those situations equals 0. So that means that we should have some applause right now, because our solutions work. We got the correct answers. 4 and negative 4 are solutions to the original quadratic equation. Those are the two numbers that make it equal 0. Now, one other way to test it out would be if our original equation weren't factored. Let's pretend that instead of it being x plus 4 times x minus 7 equals 0, that we multiplied it out. When we multiply it out, we get x squared minus 7x plus 4 minus 28 equals 0, and then I'm going to combine those two middle terms into x squared minus 3x minus 28 equals 0. So this is another representation of the same quadratic equation that we had before it was factored. How do we test out that our solutions are correct? Well, we're going to substitute them in. First, we're going to replace the negative 4 into the equation, and then we're going to replace the 7 into the equation. So you see that I've written it two times because I need to test two solutions. I'm going to put the negative 4 in wherever there's an x in the left-hand one, and the 7 in wherever there's an x in the right-hand one. And when I do that, it looks like this. And then I'm just going to do the arithmetic. Negative 4 squared is 16. Negative 3 times negative 4 is plus 12. And I have the minus 28. And the right-hand side, I have 7 squared is 49. Negative 3 times 7 is negative 21. And I have the minus 28. And then on the left side, I know 16 plus 12 is 28. And on the right side, I know 49 minus 21 is also 28. So in both situations, I end up with 28 minus 28. And we know that equals 0. So again, 0 equals 0. Our solutions work. Again, we should hit the applause button because we did a good job on figuring out what the solutions are to that quadratic equation. So coming up next will be some practice problems. The trick is, and there's a hint on there, to do these, to use the zero product property, the equation must be equal to 0. So if there's something on the right-hand side, like in number 5 and number 6, you need to move it over to the left-hand side first. And then 3 through 6, none of those are factored. Well, 4 is factored, but 3, 5, and 6 are not factored. So here are our solutions to our practice problems. On number 1, it was already factored, so I can just break the two factors apart and do the solving of the little mini equations, and I get 12 or negative 15. Number 2, I do the same thing. The only trick was that I had that 2 in front of the x in the one factor, so I needed to divide out the 2, and I get x equals 7/2 or negative 14. Number 3, I had to do the factoring first. So I have to go back to my ABC method, and you'll see my work on the right there to figure out my two factors are negative 3 and 8. And then I did the breaking apart of the 5x. I did the pulling out the common factors, factored by grouping, and I got 3/2 or negative 4. Number 4 is actually already factored for us. I have two factors. One factor is 15x, the other one is x minus 20. So I break them apart into mini equations. And on the left I get x equals 0, and on the right I get x equals 20. Now number 5, I needed to get that equation equal to 0 before I could begin to work with it. So I subtracted 36 over to the left-hand side of the equation. Again, I did my ABC factoring, and you can see my work on the right-hand side there. And in number 6, a lot of things were over on the right-hand side, the 25x and the 13, so I needed to subtract them both over to get them on the left-hand side to get a quadratic equation I could solve equal to 0 using the ABC method. Congratulations, you've made it through week 3, part 1. Contact me if you're having any problems with solving these quadratic equations. If you had any problems with the practice problems, go over them, print them, and print the solutions. And then move on to part 2 of the presentation, which will be on graphing. So I'll talk to you soon.